In our lesson today, we're going to have an introduction to 3D shapes, which we call solids. And there are two different types of solids that we're going to look at today. We're going to look at prisms and we're going to look at pyramids. And we're going to start with prisms. A prism has two parallel polygonal bases that are congruent to each other, and the sides of a prism are rectangles. Okay, so every prism will have two bases that are parallel to each other, and then the other sides are going to be rectangles. To name a prism, you name it by its base. Okay, so whatever the base shape is, that's the type of prism that you're going to be working with. And again, you name it by its base. The bases are parallel to each other. Bases are parallel. Okay, so looking at this first prism, okay, we've got to look at the two faces that are parallel to each other, and that would be the top and the bottom, and those shapes here are pentagons. And so the type of prism that this is called a pentagonal prism. The word pentagon with an AL at the end. Pentagonal prism. Okay? 5 sides on the top, 5 sides on the bottom. That represents a pentagon. They're parallel to each other. That's a pentagonal prism. The next prism, okay, again, we're looking at the top and bottom faces because they're parallel to each other. 1, 2, 3, 4, 5, 6 sides on each of those, which is called a hexagon. So this one is called a hexagonal prism. Again, the word hexagon with AL at the end, hexagonal. And then the last prism, again, we're looking at the top and bottom faces here. They're parallel to each other, and we can see that those are rectangles. So we would call this a rectangular prism. Okay, so that's all you have to do in order to name it. If it's got a parallel top and bottom, you look and see what shape those are to each other, and that's what's going to be the base, and we would call it that type of prism. Pentagonal prism, hexagonal prism, rectangular prism. So again, two parallel polygonal bases that are congruent to each other, and all of the other sides on the prisms will be rectangles. The next type of solid that we're going to look at is called a pyramid. A pyramid has one polygonal base, okay? So a prism has two bases, a pyramid only has one base. All of the other sides on a pyramid are triangles. So that's another easy way to tell if you're dealing with a prism or a pyramid. If it's a prism, all of the other sides would be rectangles, but if it's a pyramid, all the other sides are going to be triangles. And every pyramid has a point that's on the opposite side of the base, and that point is called the apex. Okay, and so to name a pyramid, you name it again by its base shape. So taking a look at this pyramid right here, okay, I can tell it's a pyramid because all of these sides are triangles. It's got an apex, and the base down here, count up the sides, 1, 2, 3, 4, 5. 5 sides is called a pentagon, so this is a pentagonal pyramid. Okay, another pyramid here. I see all the triangle sides. It's got the apex right here. The base shape right here, I can't really tell if it's a square, but I would say it's a rectangle, so I'm going to call that a rectangular pyramid. Rectangular pyramid. Okay, and then again, with our last pyramid right here, I see the triangle sides, I see the apex, and the base down here, 1, 2, 3 sides. This is a triangular pyramid. Okay, so again, with a pyramid, only one base, the sides are triangles, and it's going to have an apex, which is that point at the very top. Besides being able to name our solid, we also are going to investigate 3 parts that each solid has. Okay, each solid has 3 parts. They have vertices, they have faces, and they have edges. Let's talk about the vertices first. The vertices are the corners or the points of the solid. Okay, so every corner, every point, we call that a vertex. Plural would be vertices. The faces of a solid are the flat surfaces. the flat surfaces of the solid. So it's going to be the bases and it's going to be the other sides. Those are called faces. And then the edges are the line segments. The line segments where two faces meet. Okay, so where two faces come together, it makes a line segment, which we call an edge. On the next side, for each solid, we have to give the number of faces, vertices, and edges that they have. And to make this a little easier for myself, what I did is I used marshmallows and toothpicks to create the solid. So let's take a look at this first solid, and again, remind ourselves here, the sides are rectangles, so this is a prism, and the parallel faces, the bases, are called pentagons, so this is a pentagonal prism. Okay, and so if I show you what I did here, here is my pentagonal prism that I made out of marshmallows and toothpicks. Okay, and the marshmallows, as you can tell, those are going to be the points or the corners, and then the toothpicks are going to represent the line segments, which are going to be the edges. Okay, and so if I take a look at my picture right here, okay, and I can kind of move it all around so we can see it a little bit better. What I'm going to do is count how many. I'm going to start with the vertices, okay, which are the corners, which are my marshmallows. Okay, and if I count here, all right, I have a total of 1, 2, 3, 4, 5 marshmallows on the top pentagon, which means I also have 1, 2, 3, 4, 5 on the bottom pentagon. That's a total of 10 marshmallows, which is 10 vertices. So I have 10 vertices here. Okay, the edges are going to be the toothpicks. So if I go ahead and I count up all of my toothpicks, okay, well, I know that the pentagon is a 5-sided shape. So there's 1, 2, 3, 4, 5 on the top pentagon, which means there's going to be 5 on the bottom pentagon, and then there's going to have to be 5 more that connect the top and the bottom. 1, 2, this one right here is 3, 4, and 5 for this last one right here. So that's going to be a total of 15 edges. 15 edges. Those are the toothpicks. Okay, and now for the faces. The faces are the flat surfaces. The flat surfaces. Well, I know I have 2 pentagons, the top right here and the bottom right here, but then I also have all of these rectangle sides as well. I have 1 rectangle, 2 rectangles, 3, 4, and a 5th rectangle. So there's 5 rectangles and 2 pentagons, which is going to be a total of 7 faces. There are 7 faces here. And again, I can say that it's 2 pentagons and 5 rectangles. Okay, so this is for your pentagonal prism. Our next solid here in letter B is called a rectangular prism. Again, it's a prism because the sides are rectangles, and the top and bottom are also rectangles, so that's going to be called a rectangular prism. And again, I made one out of the toothpicks and marshmallows, as you can see here. So let's start with the vertices. Again, the corners, that's your marshmallows. I have 1, 2, 3, 4 on the top, 1, 2, 3, 4 on the bottom, so that's going to be a total of 8 vertices. Okay, the edges are the toothpicks, so let's take a look at those. The edges, the line segments, I have 4 on the top, 1, 2, 3, 4, which means I have 4 on the bottom, 1, 2, 3, 4, and then I have 4 that connect the top and the bottom, 1, 2, 3, and the 4th one is back here. That's a total of 12 edges. And now I need to count the faces, the flat surfaces. So I know I have 1 rectangle on top, one rectangle down here on the bottom, and then I have 1, 2, 3, 4 other rectangular faces, so that's going to be a total of 6 of them. All right, 6 faces, and all of them are rectangles. 6 rectangles. Okay, and so these are the properties of a rectangular prism. The next solid is called a triangular prism because the parallel faces, the front and the back this time, are triangles and the other sides are rectangles. So here's the one that I created with the marshmallows and the toothpicks. Start with the vertices, which are again the marshmallows. I have 1, 2, 3, 4, 5, 6 of them. There are 6 vertices. Okay, the edges are the toothpicks. I have 1, 2, 3 on the top triangle, 1, 2, 3 on the bottom triangle, and then 1, 2, and 3, the third one right here, to connect the top and bottom triangle. So that's going to be a total of 9 edges. And now when we count the faces, the flat surfaces, I have 1 triangle up here at the top, 1 triangle down here at the bottom, and then 1, 2, 3 rectangle faces, 3 rectangles and 2 triangles. That's a total of 5 faces. And again, it's going to be 2 triangles and 3 rectangles. And again, these are the properties of a triangular prism. The next solid is called a rectangular pyramid this time. It's a pyramid because it's only got one base. It's got the apex up here, and all the other sides this time are triangles. So I know it's a pyramid and not a prism. Okay, and the base is a rectangle, so we call it a rectangular pyramid. And here's the one that I created with marshmallows and toothpicks. Let's start with the vertices, the corners, the marshmallows. 1, 2, 3, 4, and then the apex up here is 5. There's 5 vertices. Let's go to the edges now. Those are your toothpicks. Okay, I can count 1, 2, 3, 4 along the base, and then 1, 2, 3, 4, 1 from each corner. So that's going to be a total of 8 edges. 8 edges. And now for the faces, well, I can see the base down here. That's 1 rectangle. And then I have 1, 2, 3, 4 triangles. So 4 triangles and 1 rectangle. That's a total of 5 faces. Okay, and so again, it's 1 rectangle and 4 triangles. And these are the properties of a rectangular pyramid. The last solid we're going to work with is called a triangular pyramid. Okay, so again, it's got one base that's a triangle. It's got the apex, and all the other sides are also triangles, so it's a triangular pyramid. And here's the one created with marshmallows and toothpicks. So again, start with the vertices, the corners, the marshmallows. 1, 2, 3, and then the apex right here would be the 4th. So there's 4 vertices. Okay, the edges, the toothpicks. I see 1, 2, 3 on the bottom, and then 1, 2, 3, 1 from each corner. So that's 3 and 3. That's 6 total edges. And now for the faces, okay, so we've got the base, which is a triangle, so that's 1. And then we've got 1, 2, 3 more triangles. So we had 3 along the sides here and 1 triangle down here. That's a total of 4 faces. There are 4 faces on this triangular pyramid, and all 4 of them are triangles. So these are the qualities of a triangular pyramid. So again, the corners are the vertices, the line segments are the edges, and the flat surfaces are the faces of your solid.